Hi, and welcome back. Chapter 7 talks about lean thinking, lean systems, and it's the last chapter in the process section, but a good lead into our next section, which is about quality. Lean deals with a lot of thinking, but just as the name describes, it deals with streamlining, simplifying, and getting down to the bottom line as effectively without sacrificing any other qualitative aspects. It includes some of the elements that we'll talk about and have mentioned, such as master scheduling, especially Kanban systems, setup time. These are things that we'll refer to in other chapters as well. The lean concept, again, we've mentioned Toyota, we've mentioned Deming, reached its peak in that situation in the 1960s in Japan, and the first element of it was the just-in-time concept, which said, how do you just get your parts to the point in the process that you need without having them there too much sooner or without delaying anything. In the United States, it was introduced in Lincoln, Nebraska, and what it basically emphasizes is streamlining and efficiency. In order to define it closer, you have to look at the concept of value and define for yourself what value means to your process. It drives you to look at the whole process and what we call the value stream and determine how do you make it better. And along the way, you're looking at flows of a process and trying to avoid things like waste and unnecessary duplication. Elements of a lean system, we mentioned them just a few minutes ago. A master schedule, a Kanban system, small lot sizes, quick changeover referring to setups and teardowns in your process. If you remember that you're not always going to have a high volume continuous flow type of operation, you might have job shop or some other versions, and those require a lot of setups and teardowns in between jobs. You need your workers, and your layouts are important, as well as your supplier and vendor relationships. Deming identified what he called 7 wastes in the production process, and some of these we will get into more detail. Things like too much production, too long of a waiting time, unnecessary transportation, that's moving things around more than you need to, processing things in duplicate or with too much administration. Likewise, the overproduction leads to too much inventory, and inventory can become obsolete if you don't move it. And unnecessary motion. This was one of the earlier studies that original time industrial engineers used to focus on, which is looking at people, how they work, and trying to determine whether they waste too much time or energy trying to do unnecessary tasks. And the final thing in the qualitative sense is the defects. Obviously, if you have defects, that's non-productive, it's not qualitative, and it costs you money. Okay, we mentioned inventory as a potential waste factor. Building inventory, we'll see in the next couple of chapters, is a game of speculation and forecasting. To have the exact amount of inventory at the right time and the right place when you need it is very much a challenge, and we depend on scientific tools as much as we can to try to accomplish that. The lean system, which we referred to just a few minutes ago, affects quite a bit the plant operations, the processes, and any type of operation, whether it's manufacturing or service or systems. It involves scheduling, layout, suppliers, the labor force, and it affects all parts of the organization, especially the functional aspects of it. The first thing we want to look at in this chapter is stabilizing the master schedule. A master schedule generally is a schedule that looks at levels of production, basically in units such as 1 month at a time. And the key here in stabilizing it is to try to smooth it out as much as possible and get as much visibility as you can on an ongoing basis to limit the teardown setup and other factors which increase your costs. The Kanban system was something that came out of Japan as a result of Deming's efforts, and it basically refers to a marker where in a what we call a pull production system. The other kind of system is what we call push. And what it does is identifies the marker is placed at a point where when you run below that level, it signifies that it's time for you to reorder, so you never run out at the wrong time. As we said, it signals the need for more parts. It's a simple concept and implemented in a simple way. The idea is no place in the process should run out to the point where it holds up everything else in the process. And what it really does is help you avoid buildup of unnecessary inventory and not running the risk of having long lead times at the wrong time. Kanban signals can be cards in inventory stock. They could be tags on a board. Other companies have used techniques such as golf balls or lights on a scheduling board, or there's various other techniques that can be used. It's just a way of signaling it's time to reorder. And of course, the purpose of it is to reduce, as we said, setup times and other bottleneck issues in a process. A very important part of the whole process is the people involved in it and how to get productivity out of the people. Always remember that computerized systems in themselves do not solve your problems. It's the people who work them and both administer them and use them that have to be part of it, and they are the enablers in the system. So you look at the training aspect, how people work together in teams, idea generations and suggestion systems, and total understanding between the people involved in the systematic process. Quality, always an important part. It's pretty tough, almost impossible to have a lean system without emphasizing the quality aspect of it. If you don't, you may find yourself going in the wrong direction, emphasizing the wrong things. The key thing here in a lean system, you don't fall back on excess inventory to cover up your mistakes when you make them. So being efficient is very important, and defects themselves are quickly exposed in a lean process because there's no room to fall back on errors. The last thing in a lean system is it incorporates the concept of continuous improvement, which is basically looking at things and how to keep making them better. Suppliers continuously are one of the important factors in any process, and in a value-added sense, suppliers are just as important as the employees themselves or any other element. They're an extension of the internal process, but they should be viewed as team members and not the other side or outsiders. Focus here is to get fewer suppliers so you can improve on your relationships with these people. Make sure those suppliers are dependent so that you can depend on your deliveries time, and minimize your inspection needs, which is a high cost item, by being able to depend on good quality and lower defects from your suppliers. The key in this is we are dealing with integrated systems, and the suppliers are a very important part of an integrated program. How do you assure both high quality suppliers who can work in an integrated system? Well, you have to, on the front end, you have to do a lot of work to select them. And when we say the front end, we're really talking as far up the process as the design phase. Remember earlier we talked about concurrent engineering, and that's what we're still talking about here. You have to look at your suppliers in terms of what their capabilities are, not just for a single part, but their ability to supply what we call families of parts. You want to focus on the long-term relationships, and in a lean system especially, emphasize a minimum paperwork, minimum administrative transactions in order to reduce your costs. How do you implement lean systems? Well, we talk about this in this chapter. You have the best way is usually to create a team, and by that we always like to emphasize a cross-functional team of many different disciplines. Address the value issue that we talked about and put it in perspective in terms of what the customer needs, not so much what the value is to your own organization. Develop a value stream map and use it as a driver to eliminate waste and other excess resources. Define the process on how you're going to control the flow. Get to a point where once you agree on the changes, implement them. It doesn't do any good to talk about them, to even design them, and then throw the responsibility over to somebody else to implement it. If it's your idea, you should be responsible for following it all the way through.